Graph the function represented by the table below. Is the function linear or nonlinear? So our first point is at 0, -2. If I look at A, 0, -2, there is not a point, so it cannot be A. B, 0, -2, there is not a point, so it cannot be B. C, there's a 0, -2 for a point, and for D, there's 0, -2, so it has to be between C and D. That means we go to the next point, 1, -1. So looking at C, we see this is from 0 to 5. Every other dash is going to be a whole number. So this is 1, 2, 3, and 4. This is -2 and -4. So halfway between 0 and -2 will be -1. So this will be 1, -1. So that means C is going to be my answer. Now, is the function linear or nonlinear? Well, seeing as this graph is not a line, it is going to be nonlinear. And that's the answer for number 1. Number 2, the cost C in dollars for pencils is a function of the number N of pencils purchased. Graph the function shown by the table to the right. Tell whether the function is linear or nonlinear. Now, the number of pencils is going to be the independent variable, and the cost is going to be the dependent variable, because the cost of the pencils depends on how many you're getting. So number of pencils is x-axis, and the cost is the y-axis. So looking at one number to the next of cost, they are going up by 1 each time. You add 1. Looking at the number of pencils, each dollar we go up, we add 9. So that's going up constantly. So that means it's going to be linear. So that means B will not be our graph, because linear means the graph is going to be a line. So looking at A, C, and D, there are some similarities and differences between them. Now we know that the number of pencils is going to be along the x-axis. So that means going from 0 up to a point where it includes 45 pencils would have to go along the bottom. Only one of those has that, and that's D. The other ones put 0 through 10, which is going to represent the cost along the bottom, where the cost is a dependent variable, or the y. So that means it's going to have to be D. So as we already established, it is linear. And that's the answer for number 2. 3. The length L of a pencil in inches is a function of the time t in seconds it has been sharpened. Graph the function shown by the table to the right and tell whether the function is linear or nonlinear. So the time is going to be the independent variable, and the length is going to be the dependent variable, because the length of the pencil depends on how much time has gone by with it being sharpened. So you see, for the first 9 seconds, the pencil does not change length. By 12 seconds, we see it starts to get smaller. So that tells me that, looking at our graph, we should have basically a constant graph going from 0 to 9, not changing at all, and then decreasing. So the only one that looks like that is going to be D. We see this one is the same for 9 seconds and then starts to go down. So D is the graph. So we know it is not linear because the entire graph isn't changing at a constant rate. This is not a line. We see it starts to go and then curves down. So it's nonlinear. And that's number 3. 4. Graph the function represented by the table below. Is the function linear or nonlinear? So looking at our table, looking at the x, going from 0 to 1, 1 to 2, 2 to 3, and 3 to 4, we add 1 to each number. Looking at the y's, we go from 12 to 13, 13 to 14, 14 to 15, and 15 to 16, and we get that by adding 1 each time. So since we're going up by the same amount for each number, it is going to be constant for our rate of change. Since we have a constant rate of change, it means it is going to be linear, which means our graph is going to be a line. So it's not going to be A or D. It would have to be either B or C. Now we start at 0, 12. Looking at B, we have a point at 0, 12. But if you look at C, there is no point where x is 0, which will be right here. And all along here is where x is 0. So that means our graph has to be B. And as we already talked about, the function is linear. And that's number 4. 6. For the diagram below, the table gives the total number of lines y in figure number x. What pattern can you use to complete the table? Represent the relationship using words, an equation, and a graph. Looking at our table, we're going to look for some patterns. So I notice our pattern for y is 2, 4, and 6. We are adding 2 each time. And basically what I'm doing in terms of the x's is to go from 1 to 2, 2 to 4, and then 3 to 6. I'm multiplying each of these by 2. 1 times 2 is 2, 2 times 2 is 4, 2 times 3 is 6. So basically, when I'm adding the same number on y's, that number I'm adding being 2, in this case, that's when I'm multiplying to my x. So basically, it'll be, out of my choices, be D, which says the total number of lines y is 2 times the figure number x, so 2 times my value of x. So now I'm making an equation. So basically I'm turning this sentence into an equation. We said y is 2 times x, so y equals 2x. Now my graph we know is going to be linear and increasing, so we know it can't be b because that's decreasing. To determine which of A, C, and D it is, we got to look at each graph and determine our scale. So the way to do this, count the number of dashes, 1, 2, 3, 4, 5, and 6, and divide it by the top numbers. So 12 divided by 6 is 2, so each dash is going up 2. So 2, 4, 6, 8, 10, and 12. Going across, we're going by 1 because we have 1, 2, 3, 4, 5, and 6. So we have 1, 2, 2, this will be 3. Now we don't have a 2, 3, we have a 2, 4, so it can't be A. So let's try C. So again, 2, 4, 6, 8, 10, 12, 1, 2, 3, 4, 5, and 6. We have 1, 2, this will be 2, 4, and this will be 3, 6. So that means C will be my graph. Looking at D though, we have 1, 2, 2, 4, 3, 2, 4, 6, but then 1, 2, 3, 4, 2, 4, 6. Now this is suddenly not linear. These are going up constantly, so it cannot be D for that reason. So it's going to be C. Number 7, the set of ordered pairs represents a function. Write a rule that represents the function. So what we're going to do first to figure this out is to write the coordinates vertically. So 0, 0, 1, 7, 228, 363, and 4, 112. What we're going to do next is see what we add to go from 0 to 7, 7 to 28, 28 to 63, and 63 to 112. The goal is to continually do this until all the numbers we're adding are constant. So we first see what we add to get 7 from 0. We add 7. To go from 7 to 28, you add 21. To go to 63 from 28, you add 35. And to go to 112 from 63, you add 49. So we see these numbers are not constant. That means it's not going to be linear, but put an x underneath it because this represents it being linear, because linear functions have an x with an exponent of 1 or just x. Each time we do this, and we go to the right, we add a 1 to the exponent, so the second time will be an x squared once we're finished. And then we'll keep going until everything we're adding is the same number. So now we're going to see what we add to 7 to get 21. That is 14. See what we add to 21 to get 35. And we add 14. See what we add to 35 to get 49. And it is also 14. So like I said before, write that x squared there. And these are all the same. So that tells me my equation will be an x squared function or quadratic. So we start off with y equals x squared. But we're not finished yet, because if you notice, if I substitute one of my x values in for x, say 1, I'll have 1 squared, which is just 1. It's not 7 like I want it to be. So what you do from there is you see what you multiply to this number to get that 7, which would be 7, because 1 times 7 is 7. So now take that 7 and just put it in front of the x squared. So now my equation for the answer is going to be y equals 7x squared. And I can check these. Put 2 in for x. 2 squared is 4. 4 times 7 is 28. Put in 3 squared, you get 9. 9 times 7 is 63. 4 squared is 16. 16 times 7 is 112. So this checks. So this is my answer for number 7.